Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So, in previous sessions, already we have studied about the engineering of the materials. So, in engineering tribology, the materials, engineering materials plays important role. So, why? Because the selection of material is important for proper application. You should know the properties of materials before making any product or before designing any product. So that in engineering materials, in previous sessions, we have studied some material properties and its applications. So materials are already classified into two types. One is metallic and non-metallic property metals. So these materials they classified as polymer, ceramics, and nickel coated alloys and magnesium alloys, aluminum alloys. So we have discussing one by one. So now in this session, we will discuss a small introduction about these engineering materials, and then we will go to another alloy materials and its properties. So in this introduction, engineering materials are the fundamental substances used in the construction and manufacturing of various products and structures. Already we know this about this engineering material definition. These materials are selected based on their properties and suitability for specific applications, ranging from everyday objects to complex industrial components. So everyday objects to industrial components. These are the very important the property, the selection of material. So the field of engineering materials encompasses a wide range of substances including metals, polymers, ceramics, composites, and semiconductors. So in this today's session, we will see the aluminum alloys. So what do you mean by these aluminum alloys, and what is the composition of these alloys and the properties and applications, and then we will go to next alloys, nickel-based alloys and magnesium alloys. We will see. So the aluminum alloys, those alloys are known for their excellent corrosion resistance, high temperature strength, and often their ability to maintain these properties across a wide range of temperatures. So the very wide range of temperatures it can withstand these aluminum alloys. So the corrosion resistance, this excellent corrosion resistance. So to avoid the corrosion, there these aluminum alloys uses is must. So the temperature strength also same, and ability to maintain these properties to wide range of temperatures. The composition is aluminum alloys typically contain aluminum as the base metal, along with other elements such as copper, magnesium, silicon, manganese, and zinc. These alloying elements are added to enhance the specific properties. So these alloying the composition is mainly contain aluminum as a base metal. The base metal is aluminum. The other materials are the elements are added to this aluminum base metal like copper and magnesium to improve the properties, to enhance the properties. So the aluminum alloys types are the aluminum can be broadly classified into two categories. One is wrought alloys. These are produced by mechanical working, rolling, extrusion, forging, and are used in applications where strength and ductility are important. Next, cast alloys. So these are produced by casting methods and are used when shaping flexibility and design freedom are first important priorities. So the variety wise, this the flexibility and design very important, and then casting methods are used when shaping is required. So wherever the design shaping is required, there cast alloys are used. The wrought alloys produced by mechanical working. The mechanical equipment is required to formation of these shapes, rolling, extrusion, and forging. So what are the important properties of these aluminum alloys? one is lightweight. So the aluminum alloys have a low density, making them ideal for applications where weight reduction is critical. Example, aerospace and automotive industries used these lightweight materials, aluminum alloys, because of its property low density and where weight reduction is critical. Corrosion resistance also very less. The aluminum naturally forms a protective oxidation layer and which enhances its resistance to corrosion. The corrosion resistance are very high, so that's why it can withstand the corrosion. The electrical and thermal conductivity. So aluminum is a good conductor of both electricity and heat. They're making it suitable for electrical transmission lines and heat exchangers and other applications. So machinability, the aluminum alloys can be easily machined, formed and welded and contributing to their versatility in manufacturing. So this due to this property, this machinability, you can machinable in mechanical engineering operation, the machining, cutting, and the grinding. There's a lot of process other manufacturing process. So while using these materials, it can be machinable, it can be weldable, it can be castable also. So that's why all these properties having this aluminum alloys, so that mostly very rarely frequently used these aluminum alloys in manufacturing sectors. So applications are alloys find extensive use in various industries, including transportation, automotive bodies, aircraft structures, and marine applications, and construction field, window frames, scaffolding, structural components. Next, packaging, cans for beverages and food, electronics, heat sinks, electrical transmission lines. So consumer goods, cookware, furniture, and appliances, such the consumer goods. So the major applications of aluminum alloys in these sectors, transportation sector. So while making the automotive bodies and the aircraft structures, these materials are used aluminum alloys, and construction field, window frames and scaffolding, the structural components, and packaging, cans for beverages and food, in electronics side and consumer goods also the major applications. So advantages of these aluminum alloys are high strength to weight ratio, excellent formability and machinability. So recyclability. So recyclable means the aluminum alloys are highly recyclable, saving energy and resources. You can use multiple times the aluminum alloys. That is the important the role advantage of this aluminum alloys. The challenges are also there. So higher initial cost compared to some other materials like steel. You take steel. So steel cost is very high when compared to this aluminum. Steel cost is uh, very lower than this aluminum. So initial cost is very high, and then susceptibility to galvanizing corrosion in certain environments, and specific alloy compositions are required for different applications, which may require careful selection based on performance requirements. So these are the challenges of aluminum alloys. In summary, aluminum alloys are versatile materials with a wide range of applications across industries, prized for their combination of lightweight strength, corrosion resistance, and ease of processing. Their continued development and adaptation to new technologies and applications make them indispensable in modern manufacturing and engineering. So this is the final summary of this aluminum alloys. So now we will see the nickel-based alloys. So the nickel-based alloys are a class of metallic materials that primarily consist of a nickel as the base element. Here, the nickel as a base element. In previous case, aluminum as the base element, and with other alloying elements added to this nickel-based metal to enhance the specific properties. So these alloys are known for their excellent corrosion resistance, high resistance, high temperature strength, and often their ability to maintain these properties across a wide range of temperatures. Next, nickel-based alloys composition. What is the important? The basic composition is nickel-based alloys typically contain significant amounts of nickel, often more than 50%, along with the chromium, molybdenum, iron, cobalt, and other elements like titanium, aluminum, and tungsten. These are the other elements added to the base metal. So these alloying elements contribute to the alloy's specific properties. So the specific properties are: one is corrosion resistance. So these nickel-based alloys are highly resistant to the corrosion, like aluminum alloys, particularly in aggressive environments, including seawater, acids, and alkaline solutions. So whenever present these type of solutions, it can withstand from this corrosion and high temperature strength. They retain their mechanical properties at elevated temperatures, making them suitable for applications where high strength at high temperatures is required, such as in gas turbines, aerospace components, and chemical processing plants. The wear resistance property. Some nickel-based alloys exhibit excellent wear resistance, which is beneficial in applications involving friction and wear. Fabricability. So fabrication is very important. They can be fabricated into various forms such as sheets, plates, tubes, and wires, and can be easily welded or machined depending on the specific alloy composition. The applications are aerospace application used in jet engines, turbine blades, and combustion chambers, and other components where high strength and corrosion resistance are critical, and oil and gas. So components for downhole drilling tools, valves, and piping systems, where resistance to corrosive environments and high temperature is necessary. So that these nickel-based alloys are used in oil and gas industries and aerospace industries. And chemical processing, equipment such as reactors and vessels where resistance to corrosive chemicals and high temperatures is required. And electronics, the nickel alloys are used in electronic components and batteries due to their electrical conductivity and resistance to corrosion. So that due to their electrical conductivity and the property of the resistance to corrosion, the nickel alloys are used in these electronic components. And then chemical processing units. So how many types of nickel-based alloys are there? One is Incol and Astel. So the well-known family of nickel chromium-based soap alloys known for their oxidation resistance, high temperature strength, and corrosion resistance. This is said to be Incol. The Astel alloy is another series of nickel-based alloys known for their exceptional resistance to a wide variety of aggressive chemicals. So overall, the nickel-based alloys are crucial materials in industries where performance under demanding conditions is required. So offering a balance of high strength, corrosion resistance, and thermal stability. So the versatility and reliability make them indispensable in modern engineering applications. So next alloy is magnesium alloys. So these are metal alloys, primarily composed of magnesium, often combined with other elements to enhance specific properties. These alloys are known for their lightweight material properties, excellent strength to weight ratio, and good visibility. These alloys like nickel-based alloys and aluminum-based alloys, the good machinability and lightweight properties having. Here are some important aspects given. Uh, this one is composition. The magnesium alloys typically consist of magnesium as the base metal with alloying elements such as aluminum, zinc, manganese, silicon, and rare earth elements like cerium and zirconium. These alloying elements are added to improve mechanical properties, corrosive resistance, and other characteristics. So one main base metal is magnesium, and other alloy elements are added to this base metal. The properties are lightweight property and high strength. So the magnesium is one of the latest the structural metal, very light material, and making magnesium alloys highly attractive for applications where weight reduction is critical, such as in automotive and aerospace industries. So very attractive application in these sectors. So whereas in the case of high strength property, despite its low density, the magnesium alloys can be exhibit good strength, especially when alloyed with elements like aluminum or rare earth metals. Next property is good machinability and corrosion resistance. The magnesium alloys have excellent machinability, which allows for easy shaping, drilling, and milling, making them suitable for various manufacturing processes. The corrosion resistance, the magnesium alloys can offer good corrosion resistance depending on their alloy composition. Some alloys are specifically developed to enhance resistance to corrosion in different environments. The major applications are one is automotive, another one is aerospace. So the magnesium alloys are used in automotive applications to reduce weight and improve fuel efficiency. They are used in components such as engine blocks, transmission cases, steering wheels, and interior parts. Similarly, in aerospace applications, the magnesium alloys are used for lightweight structural components, aircraft seats, and helicopter rotor blades due to the lightweight property, the very useful used in this aerospace sector. Another consumer electronics and medical devices. The magnesium alloys are utilized in portable electronics like laptops, smartphones due to the lightweight and durable properties. Similarly, in medical devices, some medical devices and implants benefit from the biocompatibility and lightweight nature of magnesium alloys. The challenge is also there. One is flammability, another one is corrosion. The pure magnesium and some magnesium alloys are highly flammable under certain conditions, which can force safety concerns. So that's why the safety, the material storing is required for while storing these materials. And corrosion, some magnesium alloys can be possible to the corrosion whenever these material are exposed to environment conditions, particularly in environments with high humidity or exposure to salt water. So their corrosion is possible. So to while storing these or exposed to any environment, so you should take the proper caring to avoid this corrosion. And types of magnesium alloys on a AZ series and W series. So this includes alloys such as AZ31, AZ61, and AZ91, where the numbers denote the percentage of aluminum and zinc added. So W series, these are magnesium rare earth alloys, which include elements like yttrium, cerium, and zirconium to improve strength and corrosion resistance. These are the materials included in this in the magnesium alloy. So finally, in summary, the magnesium alloys offer significant advantages in terms of weight reduction and strength. The major important point is the weight reduction and strength. And then in industries, due to this property, where lightweight and high performance materials are required, the valuable materials. So making them valuable materials with these properties. Advances in alloy development continue to expand their application across various sectors. Tough considerations regarding corrosion resistance and then flammability remain important in their use. So these are the basic summary of these magnesium alloys. So up to now we have studied the aluminum alloys properties, composition, and then applications and challenges. And similarly, the magnesium alloys properties, composition, applications, and challenges also we have studied. And similarly, this magnesium alloys also we have studied about their properties and composition applications. So that's why every design engineer should know about these properties and should keep in our mind these properties while preparing, while manufacturing any product or while designing any product before selection of materials. So you should think of and then select and proper materials for proper applications. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.